This unit's on perpendicular lines. Perpendicular lines are two lines that intersect to form right angles. Because lines that form one right angle always form four right angles, you can conclude that two lines are perpendicular by definition. Here is a picture of perpendicular lines, and you can see the box, which is telling you that you have 90 degrees, which is a right angle. And because you might remember from your last unit that you have a straight line here, and if this is 90, the other one must be 90 because these are going to be supplementary angles. And then the same would go for this right here. If this is 90, this is 90 because these are supplementary, and so on. These two are supplementary, and then these two are supplementary. Theorem 2.4 states if two lines are perpendicular, then they form congruent adjacent angles. Congruent means that they are the same, and adjacent means they are next to each other. And then this one, 2.5, simply says if two lines form congruent adjacent angles, then the lines are perpendicular. So it's just taking 2.4 and flipping it. Theorem 6 says if the exterior side of two adjacent acute angles are perpendicular, then the angles are complementary. What does that mean? So let's take a look at this. So here we have angle 1 and we have angle 2. And if the exterior side, meaning this, if these are perpendicular, then angle 1 and angle 2 are complementary, which means they have to add up to 90 degrees. So if this one is 60 degrees, the complement of 60 would mean that angle 1 will measure 30 degrees because the exterior sides right here of two adjacent angles, and then they're adjacent because they're right next to each other. So that's what theorem 2.6 is. So down here in the diagram below, OZ is perpendicular to PQ, and then PQ is perpendicular to XY, and then PQ is perpendicular to XY. OZ, sorry, is perpendicular to XY. So you'll notice here that OZ right here, it's coming up. It's coming out of the diagram. So they want you to name 8 right angles, 8 other right angles. So if you take a look at this, you're going to have like ZOQ is a right angle. And then you will have on the other side, angle ZOP is a right angle. And then if you go this way, angle ZOX, and then out the other way, you would have angle ZOY. Now let's see what other ones we can find. Remember this one right here, POZ is the same thing as ZOP, so we're not going to repeat that. Let's look for some other ones. So we have we got ZOQ already. How about XOQ? And then we would have XOP. We would have YOP. And I'm going to do some erasing here because I can't see. YOQ. There you go. YOQ. There's our 8. Now this is from page 57 in your book. We have BE. Line BE is perpendicular to AC. and BD is perpendicular right here to BF. Okay, so if you turn your paper on a diagonal a little bit, you'll see that that's a right angle. And then you'll also see that this is a right angle. I'm going to erase. Okay, so if CBF, which is right here, if this is 40 degrees, what do we know that EBF is? So we're looking for this. Well, if we know that you've got a right angle there, then this has to equal 50 degrees. If you want, go ahead and pause the computer and see if you can, pause the video and see how much of this you can do, and then you can put it back on and check. But I'll walk you through it. Okay, so now we have DBE. What is DBE? DBE is right here. Okay, and then we know that DBA, these two here have to equal 90 degrees. So I am going to put this back in. If that was 50, and remember that this is a right angle, which is 90, then that must be 40. So DBE has to be 40, and then DBA has to be 50, because that's a right angle. Now we're going to look at DBC. Okay, and then we knew that this is 40. So DBC is DBC. So we have 40 and 40 is 80, and 50 gives you 130. So it might be good to keep some of those angle measurements in there. All right, I'm going to erase to work the next one. So the next one we're going to have to remember our complement and supplement with the 180 minus x and the 90 minus x. Okay, so if CBF is x, which we know is 40, DBE also is going to be x because it's the same measurement. Okay, so how do we get to 50 if we know that x is 40? So looking at the relationship between 40 and 50, we know that that's 90. So if we were to have 90 minus x would get you to 50, because x is 40. We're just calling it x right now. 90 minus that 40 would give you to 50. Same thing here. 90 minus x. Now, how are we getting to 130? Looking at, we know that x is 40. If we use 90, how are we going to get to 130? 90 plus x. Okay. So down at the bottom, it's a little blurry. You might want to just go to your textbook. It says here, name the definition or state the theorem that justifies the statement about the diagram. So if angle 6 is a right angle, then RS is perpendicular to TV. So if this is a right angle, well, that's just going right back to our definition of perpendicular lines. That was the first thing that we had written down, definition of perpendicular lines. It's telling us that if we have lines that intersect and one of them is going to be a right angle, then we know that they have to be perpendicular. So number 7 is if RS is perpendicular to TV, then angles 5, 6, 7, and 8 are right angles. That's also the definition of perpendicular lines. You can go ahead and flip back to their notes and take a look at that. If RS is perpendicular to TV, then angle 8 is congruent to angle 7. So that is 8 and 7 are adjacent angles. So that's looking like if two lines are perpendicular, they form congruent adjacent angles. So that's Theorem 2.4. Because it's telling you right off the bat that they're dealing with perpendiculars. The perpendiculars are creating congruent. If you look at 2.4, it says if they're perpendicular, then they create congruent. So that's how you know they're dealing with 8 as opposed to, with 2.4 as opposed to 2.5. So number 9 is if RS is perpendicular to TV, then the measure of angle 6 is 90. That again is back to definition of perpendicular lines, because they're talking about measurements here. And so your measurements are your definitions of perpendicular lines. Okay, number 10, if angle 5 is congruent to angle 6, then RS is perpendicular to TV. Okay, so now we're talking about congruence first. Which theorem mentions congruence first and then the perpendicular? That's going to be Theorem 2.5. And then the last one, if the measure of angle 5 is 90 degrees, then RS is perpendicular to TV. Again, that's your definition because they're talking about those measurements. This is a very rough sketch of one of the diagrams on page 58. And we're going to be doing some of these for homework, so I just wanted to give you a practice problem. This is number 9. So it's telling you that BE is perpendicular to AC. So you know you've got your right angles here. And it's also telling you that BD and BF are perpendicular. So this is just like the other one, where you also have a right angle right here from this guy. Okay, so it's saying that ABD is 2x minus 15. So that's right here. And DBE is x. That's right there. And they need you to find the value of x. So based on the information that you've been given, this is 90 degrees. So we have to do 2x minus 15 plus x equals 90, because both of those added together will give you 90. So then we have 3x minus 15 is 90. Add 15 to both sides. 3x is 105. Divide by 3. And x is 35. You are going to be working on the written exercises on page 58, 3 through 12. In the ones 3 through 8, it's very similar to what we just got done doing, except you might have to go back and your definitions might be complementary or supplementary angles. So you're going to go back to section 2.4.